In this lesson, we will review basic concepts of ratio and proportion. We will also solve some applications from chemistry, including multimole conversions in a chemical equation. Let's get started. So once again, we always begin these examples in our video series with very simple examples, and from there we're going to build up towards more complicated ones. And in this basic example, we have this information provided to us that 2 pounds of oranges equals $3. The question is to fill in the blanks first of all. What will be the cost of 4 pounds of oranges, 10 pounds, and then eventually 5 pounds? And then we're going to build from there. So let's begin by 4 pounds of oranges. So clearly we see there a doubling ratio, right? So from 2 pounds to 4 pounds, this is exactly double the amount. So one would expect that the price will exactly double. Therefore, you would expect there to get $6. So this is just by using intuition, no specific math formulas involved, right? Just by seeing the doubling pattern in this given question. What about the next one? For 10 pounds of oranges, once again, it's not too hard to observe that, from 2 to 10, they multiply by 5. This is a 5 times of the given quantity. So you would expect the price will multiply by 5 as well. So there the price will be $15. Now, what about the price of 5 pounds of oranges? That's where it gets slightly trickier because it's not a whole number multiple. Although you may have realized going from 2 to 5, technically you have multiplied by 2.5. So you do the same thing over here and you multiply 3 by 2.5 and you'll get the answer. But sometimes the numbers are much messier and you don't see exact pattern. So what I'd like to show you is what would you do when the numbers are very messy. And once we develop this procedure, we will actually do things like, what if you have 3/4 of a pound of oranges? What would be the price of that? So it's good that we already have an idea what the answer will be for this one, but let's actually do the math. Okay, so in method number one, if we have 2 pounds of oranges is $3, first we're going to figure out, okay, what is 1 pound of oranges equal to how many dollars? So if 2 pounds is $3, 1 pound basically, it's going to be half of that amount, right? So divide 3 by 2. So you have 3 over 2. And in decimal language, that would be $1.5. So the price of 1 pound of oranges is $1.50. And from there, we can answer for 5 pounds of oranges, if 1 pound equals $1.50, then 5 pounds of oranges will be 5 times that amount, which will be 5 times $1.50. In other words, $7.50. Okay, so that was our method number one, converted to single units, and then from there, we're able to get whatever we want, like 5 pounds in this case, multiplied by 5. Okay, method number two, this is the most commonly taught method in your math classes. We can actually set up some equations, some proportions. So what we know is that 2 pounds of oranges, so let's just say 2 pounds of oranges. So we do know that it's $3, so the ratio of 2 pounds of oranges to $3 must be the same as the ratio of, right now we want the price of 5 pounds of oranges. So we don't know the price, so let's just call that X dollars. So since all the units are exactly the same, like here on the numerator you have pounds of oranges, and denominator dollars and dollars, you could basically divide everything by those and just worry about now the actual values, 2 to 3, 5 to x. So here you have the ratio of 2 to 3 equals the ratio of 5 to x. And the way we solve these equations typically is cross multiply. And just as a refresher, if you have a single fraction on the left-hand side and a single fraction on the right-hand side, then you can cross multiply. That means 2 times x will be equal to 3 times 5. That's a very good technique to solve equations when you have single fractions on either side. So here we're going to have 2x equals 15. And to solve for x, since this is being multiplied by 2, divide both sides by 2. X equals 15 over 2. which is also 750. Okay, so we got the same answer that way. And the last approach is an approach that you might see in your science classes, specifically in chemistry. So we are trying to obtain the price for 5 pounds of oranges. And so the question is how many dollars? So I'm going to say, okay, the unknown is how many dollars, and the given is 5 pounds of oranges. Okay. Now here you would use a conversion factor. What we do know is based on the given information, 2 pounds of oranges equals $3. So since I want to end up with the dollar amount, basically these two are equivalent quantities, so I can put them on the top and the bottom of the fraction, and the ratio will be 1. So you're not changing anything. 5 pounds, basically you're only converting the units, basically. The numerical values will be the same, will be preserved. Now, here's a question though. Would you put the 2 pounds on the top, $3 on the bottom, or vice versa? The 2 pounds on the bottom and $3 on the top. And always look at what you're trying to end up with. If it's dollars, you want to have the dollar amount on the top. So here we're going to have $3. And I'm just putting the dollars at the end. Usually, typically, most units we put them on the right-hand side. So just I'm being consistent there. And then the 2 pounds on the bottom. 2 pounds of oranges. So now we can cancel the pounds of oranges units. And look what we have in terms of numbers. 5 times 3 over 2, which is 15 over 2. So there we also have the same answer. In other words, $7.50 for 5 pounds of oranges. So each one of these gave us the same answer. And I think it's good to be familiar with each of these approaches. And depending on the problem, you may choose your selection, pick one of these. In chemistry, you're most likely going to use this approach. But knowing the other approaches, especially this one, will give you a choice, to check your answer sometimes doing a different method. Those are always good things to know. Now let's do another example. Okay, so as promised, how much would 3/4 of a pound of oranges would cost? So 3/4 pound of oranges. How can we determine the price for that? And once again, I copied down our basic given proportion. So 2 pounds of oranges equals $3. So now we want 3/4 pound of oranges. In the first part, I'm going to do it with the ratio proportion method that you usually do in your math classes. So let's set up the simple proportions. The ratio of 2 pounds to $3 on the left-hand side must be equal to, on the right-hand side, okay, we want 3/4 pound of oranges. So I put that in the numerator. Again, the important thing is if your pounds of oranges are in the numerator on this side, you want to put that quantity in the numerator of the other side. You must match, you must be consistent. Whatever you did on the left-hand side, follow the same pattern on the right-hand side with this approach. And the question mark, how many dollars? That's the unknown. And I can replace now the question mark simply by x. And we can solve this equation by using the cross multiply method. So simply multiply 2 times x equals to 3 times 3/4. So 2x equals 3/4 times 3. And let's simplify the right-hand side. You can regard the right-hand side as 3/4 times 3/1. So product of two fractions in a way. Multiply the tops, multiply the bottoms, and you get 9/4. So now you have 2x is equal to 9/4. How can we solve for x? We're going to need to get rid of that times 2 next to x, right? And we will do that by dividing both sides by 2. Now dividing both sides by 2 can also be written as follows. You can basically multiply both sides by 1/2. That's the same idea there. Multiply by 1/2. So the 2's cancel there. And on the right hand side you have 9/4 times 1/2. If you simplify that, you get 9/8, or as a decimal, this value, and typically dollars and cents rounded to nearest hundredth, so we have $1.13 for 3/4 of a pound of oranges. Now let's do the same thing with the approach from chemistry, and you will see that that approach really saves time. Okay, so given value does not change. We still have this. So first of all, on the left-hand side, I'm writing what we're supposed to end up with. We want to know how many dollars. And on the right-hand side, what's given. We're trying to determine the price of 3/4 of a pound of oranges. So I wrote down what's given. And here is our conversion that was given to us. 2 pounds of oranges equals $3. So now use that and decide where you would place the 2 pounds and where you would place the $3. So if you're trying to cancel out the pounds units, and to be left with the dollars units, so the dollar figure should be on the top, right, and the pounds value should be on the bottom. So let's put it in that way. So it's going to be $3 will be on the top, and 2 pounds of oranges on the bottom. Again, the idea being this conversion factor represents 1. It doesn't change the value of anything, but it changes into the correct units. In this case, from pounds, we're going to dollars, basically. So we're going to get the correct value for dollars. And simplify this. You have 9/8. So in one swift move, one simple setting up there, instead of doing several steps like we did earlier, you can actually get the result. So the answer will be, first cancel out the units, pounds of oranges from the top, cancel with pounds of oranges from the bottom. So we have 3 times 3 is 9, over 2 times 4 is 8, and the remaining units are dollars. So 9/8 dollars, in other words, roughly $1.13. So that will be the price of 3/4 of a pound of oranges based on the given information. Okay, in the next few examples, again, you may decide to choose just one or the other method. I may, again, show you both methods at times, but I would say it's up to you. And if for your chemistry classes, I want to encourage also the use of the method that we see on the right-hand side. Okay, so here we have an application from chemistry. You may see this under the topic of mole-to-mole conversions in a typical intro to chemistry class. It looks very different, but I'd like to show you in a few moments that this is really very similar to the oranges example we just completed. So you have a somewhat complicated looking chemical equation, but at the moment all we have to be concerned about is that the way we're going to read this is basically look at the coefficients 2 units, and typically we're going to talk about moles. So let's say 2 moles of hydrogen plus 1 mole of oxygen will produce 2 moles of H2O, or water. So the only thing that we need to pay attention here, because this is just trying to point out to you ratio and proportion things that from chemistry. So just look at this, that when the coefficient here is 2 moles of that quantity, this coefficient has to be 1 mole of oxygen, and this coefficient has to be 2. And it's given that in a chemical reaction, the ratios of substances in moles used up and formed must stay the same. So these ratios will always be the same. The 2 to 1 to 2 ratio in terms of moles will remain the same. So that means, to answer the question here, determine the number of moles of oxygen that would be required or needed to react with 4 moles of hydrogen. So we're going to use the same ratios. So we're given 4 moles of H2, and we're trying to determine the number of moles of O2. So the ratio between H2 and O2 based on the given coefficients in the given equation was 2 to 1. So now they gave us 4 moles of H2. And again, the typical ratio was 2 to 1, or just take half of that. You're going to need half as many moles of oxygen. So if we're given 4, here we can see a clear pattern. Therefore, this has to be 2. In other words, for 4 moles of hydrogen, we're going to need 2 moles of oxygen. Okay, and also the question asks, how about how many moles of H2O or water needed? And the typical units conversion there was, we were given hydrogen, so 2 moles of hydrogen will produce 2 moles of water. So the ratio there was 2 moles of H2 produces 2 moles of H2O. So here we are given 4 moles of H2. So as you can see, it has to be exactly the same based on the given proportions. So it'll be 4 moles of H2O. So that is the answer for how many moles of H2O will be formed, and that is the answer for how many moles of oxygen will be formed. Let's take a look at another example. As a matter of fact, it's the same one, but we're going to have a few more parts to it now. So when 4 moles of hydrogen that was given to us, number of moles of oxygen produced or reacting with H2, we've determined that to be 2. I'm just filling the table based on information obtained above. And then 4 was the answer for the number of moles of water. Now let's see that. Look at the table. Now we're given 3 moles of oxygen is given. Then can you fill in the blanks? As a matter of fact, can you fill in the remaining part of this table and then come back and check with us for the answers? And I will just copy down the given ratios. It was 2 to 1 to 2. So this is always going to remain constant. This ratio 2 to 1 to 2. So if you take 2 moles of this substance, 1 mole of this, resultant will always be 2 moles of that. So now we know this one is 3. So can you fill in the blanks for the next 2 boxes? So clearly 1 to 2 ratio, you have to double it. So this will be 6 moles of this substance. And same thing here, 1 to 2 ratio, this will also be 6. Now if this is the given quantity, 0.4 moles of H2O, from there to there, what should we do? Divide by 2, right? Because it's a 2 to 1 ratio. So that'll be 0.2 or 0.2 moles. And from there to there, it's a 2 to 2 ratio. That means the same amount. Whatever you use here will be the same there. So 0.4 or 0.4. And over here again, 7 is given. From there to here is 2 to 1 ratio. So take half of that, 3.5 moles of oxygen will be needed. And from there to there is the same ratio, or just 7 moles of hydrogen needed. Okay, we have another example that is somewhat similar. So this time a more complicated looking equation, but the idea is still the same. You have 4 moles of NH3 or ammonia plus 5 moles of oxygen, resulting in 4 moles of nitrogen oxide and 6 moles of water. So the question is, if you begin with 8.0 moles of ammonium, how many moles of the other 3 substances are you going to need? How many moles of oxygen can react with that? And what will be the resulting nitrogen oxide and water values? How many moles of those will be produced? So please take a moment to try this on your own first and then come back and check our answers. And the given ratios are 4 moles of this quantity will react with 5 moles of this quantity, resulting in 4 moles of this and 6 moles of water. Okay. Now the first one is actually pretty simple because it's an even number, a whole number multiple. So like from 4 to 8 is exactly double the amount, right? So can you see what the other values are going to be even without having to use any formulas or equations or conversion factors? It's just going to be, if this is 8, everything has to be doubled, right? The ratio was 4 to 5, so it should be 8 to 10. And here, It's 4 to 4 ratio, so this should be 8 to 8, so it should be the same thing. 0.0. And here, again, it's 4 to 6 ratio. So we need to know, once again, it's just being doubled. From 4 to 8, it's been doubled. So if this is going to be 6 to 12. And let's check significant figures. Because it was given 8 points here, it had two significant figures. This should also have two significant figures. So I'll put a period there, or decimal place. 8 points here and 12 both have two significant figures. Okay, let's check the next one. 15 moles of water. That will require how many moles of these two substances and how many moles of this will be produced along with 15 moles of water. Okay, I'm going to begin with the first one. And notice the moment you determine the first one, you will already know the answer for the third one, for the nitrogen oxide, because those are 4 to 4 ratio. So whatever this is, this will be exactly the same. And I'm going to follow the approach from chemistry as I do this example. So we are given 15.0 moles of H2O. We're trying to end up with an unknown moles of NH3. And we need to write a conversion factor over here based on the given equation. What is the conversion factor between NH3 and H2O? So it was 4 to 6. So I want to put the H2O moles on the bottom, so the moles of H2O will cancel, right? So given information tells us 6 moles of H2O will be produced when 4 moles of NH3 are used. Let's cancel the common units, so moles of H2O, moles of H2O. And the answer is 15.0 times 4 over 6 moles of NH3. And if we simplify that, we're going to have 60 over 6 or 10.0 moles of NH3. And here I've rounded to 3 significant figures. The reason is the given expression had 3 significant figures, and we're assuming that this is the only measured quantity here. We're assuming that the given coefficients of the equation are exact values, and they're not going to limit the number of significant figures in our final calculation. So the only thing that will restrict is the given measured quantity. So I will fill out the table with the value we obtained. We have 10.0 moles of NH3. So here we have 10.0. And remember the 4 to 4 ratio in the given equation. So these are exactly the same amounts. Whatever this is, this will be the same. So 10.0 moles of NH3. That means this will be 10.0 moles of NO. So can you now go ahead and figure out this value? How many moles of oxygen will be needed in this equation? And here's the answer to that question. Number of moles of oxygen, that's the question. Given was 15.0 moles of water. We put the ratio, the conversion factor that we know between between water and oxygen. The ratio was you need 5 moles of oxygen to produce 6 moles of water. 5 moles of oxygen for 6 moles of water. And the way we put this is because you want the moles of water to cancel. So we're left with moles of oxygen. When you do the math, you get 12.5 moles of oxygen. So you can fill in this space with 12.5. And that concludes our presentation part 1 on ratio and proportion.